Yeah, hello everyone. My name is Print Kumar Singh, and I'm a student of Purnima University. And right now I'm in my third year, fifth semester. And today I'm going to present one of the today I'm going to present logistic regression, which I had implemented it from scratch. So let's jump back to the code. Okay, so let's okay, so yeah, so okay. So first we had did we just imported our basic libraries that we are going to use while implementing a logistic regression from scratch. And and this is our sample data which I had created from ChatGPT for logistic regression. Yeah. And oops, it's a wrong data. Just a minute. Mm, mm. Okay, so yeah, this is the basic import that we had that which we are going to use in our while we will be implementing logistic regression. And this is the sample data that I had created using the ChatGPT. Okay, and so yeah, what we had is X and Y. X is our features and Y is our target, like feature column, and Y is our target column. And before, like, yeah, it's kind of very similar to, like, the implementation part is very similar to um, mm, linear regression and multiple linear regression. But here, the main institution or the main idea is we will be just converting the probabilities the predicted probability into 0 and 1 format using sigmoid function. Yeah, that's the main idea of it. And here we don't need to normalize the data, which we used to do, which we had done in linear and multiple linear regression while implementing it. So yeah, first we had created a logistic regression class. There we had initialized a construct. Basically, we had initialized a constructor which has LR, that is learning rate, which had been set to 0.02, max iteration to 1000, and tolerance to 10 is to power minus 6. And initially we had initialized the value of weight and intercept to none. Okay, and we had again initialized a function, not exactly function, a method, sigmoid. Okay, uh, sigmoid, which will be receiving a z value. Okay, and that like z value or column, and then it will be returning uh, the sigmoid. Okay, it will convert that value into sigmoid function. Not exactly sigmoid, like basically that will. So basically, it will receive the value, and this is the basic. Basically, this is the formula. Okay, and it will pass through it, and it will return. It will convert those value into 0 and 1 format. Okay, and here is so basically it's def compute loss. So basically, it will be computing our loss value, which is basically the modified version of this what modified version of the loss function that we had earlier in multiple regression and linear regression. Yeah, so basically what we call it, it's binary cross entropy loss. Yeah, so basically the name of uh, this function, okay, the proper name of this function is binary cross entropy loss, and from this we will be calculating our loss. Okay, with the help of this we will be calculating our loss every time when the loop runs. Okay, and then afterward we had initialized a fet method where we will be getting two values, x and y. Basically x having the features, and y like the feature which is independent, and y which is our target, and which target column which is our dependent, okay, dependent column. And here again, we had M and N, which basically M will store the what basically the row size of X features, like X column, and N is basically the column size of X. And here again we had initialize our weight with zero column, and intercept to zero. And this is again here we had initialized our y value with a okay, with basically we had converted reshaped into into one shape. Okay, and afterward we had what is this previous loss. Yeah, so basically at first we will be initializing it with positive infinite value, and afterward we had this loop which where we can doing our main calculation, and the loop will run till it reach either this condition trues, or it completes its iteration till 10 to 100, basically 1000. And what is this? Basically, here we are basically here we will be computing our loss. Okay, and this code will be execute. Basically, it will what it will do. It will calculate our y hat. Okay, and afterward we will be calculating our gradient descent, which is the partial, which we here which will gradient descent. We okay. Mhm. Okay, so here what we had did is we had did the partial differentiation of first is basically we had did the partial differentiation of loss function with respect to weight, and then afterward we had did partial differentiation with respect to intercept, and afterward we had just updated the value of gradient descent. And again, after calculating gradient descent, we will be calculating the loss. Okay, and after calculating the loss, we will just jump back to this if condition. If we will check if it's like the absolute of previous loss minus loss. If it's greater than, if it's less than 0.10 to power minus 6, we will just break the loop. Okay. Okay. And if that condition is like, if we didn't reach that condition, we will just change our previous loss to current loss. And afterward, we had two methods. One is predict probab, where here we will be calculating our probability, and this the second is predict, which where we will just turn the predicted value, like if it's the predicted value, the value which if we get the value which we get is greater than 0.5, we will just convert into 1, and if it's not greater than 0 0.5, we will just convert into 0. Okay, and then we had used train test split thing, and yeah, divided our column into two separate sets. Okay, the column basically data into two different sets. Okay, okay. First one is train, and the second one is test. Okay, okay, and yeah. And then afterward, we had initialized our class with the name model, and then we had just like use that method to process the data, and afterward we had predicted the value. You first one is predicted the value in 0 and 1 format, and the second one is predicted the probabilities. Okay. And then these are the values like which we had predicted. And let's talk about this thing, which is the evaluation, the main part of the main part, like where we will be checking if our how our model is performing. So for that, we had used multiple things like multiple evaluation matrices. First one is accuracy. The second one is precision. Third, recall. Fourth, F1 score, and fifth one is a confusion matrix. Okay, it's not an evaluation thing, so it's more like yeah, it's evaluation. Yeah, it's evaluation. Okay, and okay. So accuracy is 96, precision 97, 97. Okay, it's very same. Like these three are giving me the same result, like, yeah. And accuracy is 96. Okay, okay. And here we have this confusion matrix. So it's true positive. What is this? Uh, false. True positive, false negative, and system. Mhm. Okay. So basically, this is the act. Okay, so this is basically what uh, actual predicted zero, that actual predicted true. Okay, and this is actual predicted false. Like okay, so it's actual predicted negative and basically the false, and this is actual predicted positive. So if we see, we had only like one and one. Okay, there are like two times in that, there are two times where we failed to predict our values, and the rest of the time we are able to predict our values. So yeah, this model is like working perfectly, yeah, because we had cal basically we had generated a data set especially for to perform logistic regression. So yeah, that was quite obvious. Mm. Okay, so that's it uh, for this video. Yeah.